Okay, to solve question 54 from the Advanced Algebra 2 homework, it says the graphs of each pair of functions intersect. It says to find their points of intersection without using a graphing calculator, and the hint is to solve as a system using substitution. Now this is a system. A system just means more than one equation. We have more than one equation. These equations both involve two variables x and y. So we have two equations and two variables. So we can solve using substitution or elimination. They say to use substitution, and the reason being this top equation here has already been solved for the variable y. So we can simply take this and substitute it into the other equation, giving us x squared equals a negative 1/2 x squared plus 3/2 x plus 3. Just remember with substitution not to plug the equation into itself, because then what you would actually be doing is comparing an equation with the exact same equation, which is going to seem that it always has an infinite number of solutions. So as long as you plug it into the other equation, you're okay. Now because we're solving, we're finding the solution to the zeros to this quadratic function, we want to set this equal to 0. When we do, we subtract x squared from both sides, giving us a negative 3/2 x squared plus 3/2 x plus 3. Now because this is an equation, we can multiply, divide through. As long as we do the same thing to both sides, this equation will remain balanced. You don't have to do this. In order to solve, you could use either the quadratic formula or something else. I'm actually going to factor. So what I'm going to do before I factor, I'm going to make this a, this coefficient here of the x squared term, 1. And the way that I'm going to do is I'm going to multiply through by a negative 2/3. And the reason I'm going to do that is because when I multiply through by a negative 2/3 here, this b will just become negative 1. In here, this will just become 2. So this won't be bad. And then when I multiply over here, it's just going to remain 0. So if I multiply by a negative 2/3, anything I do to one side I have to do to the other. What I have is 0 equals, this is going to be x squared, because when I multiply this, it's positive 6 over 6. So that's 1x squared. I'm going to have minus x here, because this is going to be negative 6 over 6. So it's going to be minus x. And here, it's going to be negative 6 over 3, which is a negative 2. So my equation is now 0 equals x squared minus x minus 2. So I'm going to attempt to factor this. Okay, I have three terms. A is 1. This quadratic, therefore, I know is going to factor in the two binomials. First term in both binomials being x. Okay. The final term is negative 2, so I know I'm going to have a negative and a positive. I know the larger of the two terms needs to be negative, because when I add the product O and I together, I'm going to have a negative 1. I need to figure out what multiplied together gives me negative 2, when added together gives me negative 1. That's going to be easy. It's negative 2 and positive 1. So if I wanted to check this, first times first is x squared. Outer is going to be x, inner is going to be negative 2x, giving me the negative x. That's the sum of the products O and I was just referring to, and then L times L is negative 2. From here, zero product property would say if the product is 0, if either of the factors are 0, then in fact this product will be 0, which would give us a solution. So here we have x equals positive 2, and here we have x equals a negative 1. Now, if we plug these values into either one of these functions, we should get the corresponding y's. It's going to be easiest, in my opinion, to plug in to this top one. So y equals x squared when x is equal to 2. Y is equal to 4. So the point of intersection would be 2, 4. They should both have those in common, and we can plug in here to check. And then we have y equals x squared, plug in a negative 1. Squaring a negative 1 leaves us with positive 1. So in this case, we have negative 1, positive 1. Now, if you want, you can continue to watch. We'll try to graph these using fluid math. We'll graph the first equation of the system, and we will graph the second equation of the system. See, this needs to be negative. See if we can get that negative in there. That didn't work all that well. There we go. Negative 1/2 x squared plus 3/2 x plus 3 when we graph that, we think that the intersection is negative 1, 1, and 2, 4. Let's take a look here. Yeah, we have negative 1, 1, and here we have 2, 4. So in fact, those are the 2 points of intersection for this system of quadratic equations. And that is how you solve question 54. And you would solve 55 the same way. So if you still have questions, just let me know and I'll post another video. But I think from here you can probably take it over. The answers for 55 are going to be 0, negative 2, and 2, 2. So give it a shot, and if it still doesn't make sense, let me know.